all you have to do is give us your 90 days and we'll help you in upskill and grow. So choose your favorite course, go to our website, start learning, and we are ready with your refunds. We have helped thousands of students and they have got more than 5 crore rupees of refund. So it's not only helping them in monetary terms, it's also helping them in being consistent and complete the course. So last year our completion rate was 20%, and with 390 challenge, we have seen it significantly going up. See, the idea of 390 was to make students motivated in the form of money, so that they complete the course and they get money. But our main aim was to make students consistent so that they become market ready.
All right, so hi everyone. I guess we are live now. Welcome back. Myself, Ayush Tripathi, currently working as a mentor at GeeksforGeeks, and welcome you all to this post-analysis discussion of last weekly contest 189. So write a quick +1 if I am audible, and also rate the entire contest on a scale of 10, so that we can improve the upcoming problem set and this discussion. So how was your contest, everyone? How many problems you were able to solve? Second question solved nahi hua, sir. Okay, that's fine. What about the rest of the questions, facts and the myth? Okay, 2 TLE. Second question gave TLE. And I personally consider the second problem was really nice. You just have to write some mathematical formula and that's enough. So let's just start the discussion with the first problem. And for this, for all the 4 problems, there is no prerequisite at all. Cool. So just allow me 1 minute. Even ChatGPT failed a second question. Yeah, most of the time, these AI models will not give you the correct solution. So let me just share my screen. So this was the first problem of the contest. So I guess we can have some better template, and I usually prefer this one. So let's just go with this template. So this is the first problem. Number difference. So in this problem, you are given a number n, and your task is to calculate the difference between n and its inverted number. And basically inverted number of n is obtained by flipping all the bits in the binary representation. So if it is 0, then in inverted number it will be converted to 1, and if it was 1, then it will be converted to 0 in inverted number. So let me just give you some example. So let's say we have some number n whose binary representation is 1, 1, 0. Then let's say we have 0, then 1, 0, 0. So this is the binary representation of n. So what will be the inverted number? So one thing that we don't need to consider the leading 0. We have to start from where we have our first set bit. So also let me write the weight of each and every bit. So this bit has weight 2 power 0. Then this one 2 power 1. We all know the weight distribution in binary form. So then 2 power 2, 2 power 3, 2 power 4, and finally we have 2 power 5. Cool. So initially, let's just initialize the variable difference, and here I will store my answer and initialize this variable with 0. So what will be what we will get if we invert all the bits of n? So if I flip all the bits, then here we will have 0. Then here also we will have 0 because 1 will be converted to 0 and 0 will be converted to 1. Now at here we will have 1. Then here we have 0. Then again 1, 1. Cool. So what does it mean? It simply means if we have a bit set in n, if we have a bit set in n, then it will be 0 in inverted number, right? So I simply say if we have a set bit in n, then I will add its bit in my difference variable. So bit 5 is set. So I will add 2 power 5 in my difference variable. Now the next bit is 4. It is also set. So I will add 2 power 4. Then we have bit 0. So here in this n, we have a bit 3, which is 0. So it will be converted to 1 in inverted number. So I will just simply subtract. I will simply subtract 2 power 3. So minus 2 power 3. Then we have a set bit. So plus 2 power 2. Then bit 1 is unset. So simply subtract 2 power 1. Then bit 0 is unset. So subtract 2 power 0. So this is my final answer. A very straightforward solution. If we have a bit set, then I will increment my answer by its weight, because in inverted number it will be 0. And if we have a bit 0, then it will be set in inverted number. So I will subtract, because eventually I need to find the difference, my difference, which is equals to the actual number, which is n, and minus inverted number. So this is the complete approach. Clear to everyone? Write a quick +1 if this approach is clear to you. Yes, Shubh. The fourth problem was also appear in weekly contest 187, but in that contest, the constraint was up to 10 power 4, or I guess 10 power 5. So that's also allow you to write the linear time solution. But in the post contest discussion, I have explained the solution which can solve the problem in logarithmic time. We'll discuss the same solution here. So let me just show you the implementation. And here we have our bit count, basically the current bit number. And this is my difference, or I can say my answer, which I have initialized with 0. Then while the value of n is greater than 0, I am simply checking the LSB. If LSB is set, then I will increment my difference by the weight of current bit. and if it is if it was 0, then I will subtract the weight of current bit from my difference. Cool. And then here I am simply removing this LSB and incrementing the bit count, basically the current bit number. So previously we were at 0. Now the next bit is 1. Now after this the next bit number is 2. So I hope this thing is clear to everyone, because this is very straightforward. And finally I will return my difference. And what will be the time complexity? Here the time complexity will be n log of n. Simple, log of n base 2. So this will pass all the test cases, and you cannot write a linear time solution because the value of n can be up to 10 power 9. Let me just check the constraint. Yes, it is up to 10 power 9. So yeah, there exist multiple ways to solve this problem, and here I have explained one of those method. So let's just move to the second problem, which was really nice. Good pairs. So here in this problem, you are given two integers n and k, and a pair x comma y is considered good if x is greater than or equals to 0 and less than or equals to y, and this y is less than or equals to n, and their difference y minus x must be divisible by k. Cool. And our task is to count the total number of such pairs, and since the answer can be very large, so we have to return the answer under modulo 10 power 9 plus 7. So let me explain you this first sample input. N is equals to 2 and k is equals to 2. So n is equals to 2 and k also equals to 2. So here how many pairs we have whose difference is divisible by k? That is y minus x mod k is equals to 0, right? And the value of y less than or equals to n, the value of x less than or equals to y, and it is greater than or equals to 0. This These two informations we have for x and y. So how many pairs exist? So for this sample input, the pair 0 comma 0, which has a difference of 0, so let me write it this way. So this is my x, then y, and here I will write the difference y minus x. So if I select x as 0, y as 0, then their difference would be 0 and it is divisible by k. And if I select this x as 1 and y as 1, then the difference is 0 and it is divisible by k. If I select both the values as 2, then also the difference is 0 and it is divisible by k. And after this I can select one more value. I can select here I can select the value of x as 2 as 0 and the value of y as 2. So now their difference is equals to 2 and it is divisible by 2. And these are the only four possible pairs we have. So my answer is simply equals to 4, which is same as the expected output. Now the second sample input, n is equals to 5 and the value of k is equals to 1. So in this case, the value of n is equals to 5 and the value of k is equals to 1. So I need to check how many pairs we have whose difference is divisible by this one, or basically every number is divisible by 1. So in this case, we would have 21 such pair. So let's just quickly discuss the approach. So first of all, tell me guys, how many numbers we have which are less than or equals to n and divisible by k. So basically I need to satisfy this condition. Y minus k, y minus x mod k is equals to 0. And the value of y less than or equals to n, the value of x less than or equals to y, and it is greater than or equals to 0. So I need to satisfy this condition. So we all know that the difference, which is y minus x, is also less than or equals to n, right? Because both the values are less than n or equals to n. So how many numbers we have which are divisible by this k? So isn't it all the multiples of k? So the multiples of k, which is 0, I can say 0 into k, then I can say 1 into k, then I can say 2 into k, and up to let's call our integer count, and count into k. So count into k is the largest multiple of k, which is less than or equals to n. Largest multiple of k which is less than or equals to n. And what will be the value of count? So the value of count is nothing but simply n divided by k. The largest multiple of k which is less than or equals to n. So I will take the floor value. This is the value of count. Now the next thing. Here the next thing. Let's call this as a set. So let's say we have this set which simply have the elements as a multiple of k which is less than or equals to n. Cool. Now here from this set I will select some element, right? So I will select some element. Let's call some element as g. So let's call this element as g. So this is my g, and now I need to find the number of pairs whose difference is equals to g. So here in this case the value of g is equals to 2 into k. So I will iterate over all such g, right? And now let's just fix this x. So if I fix the value of g, right, and the possible values of g over is the element of this as set s, right? And let's say I have fixed some element x. Now what will be the value of y? If you know the difference, if you know the first element of the pair, then what will be the value of a second element? Isn't it x plus g? This is the value of y. So this is the value of y, x comma x plus g. This is my value of y. And now if you find the difference, then their difference would be simply equals to g minus x plus g minus x, which is equals to g. So this is the value of y, right? And this value must be less than this g plus x must be less than or equals to n. Or I can say the possible value of this x must be less than or equals to n minus g. and I will increment my count by that number, right? And here I will do this thing for all g, which belongs to this set S, or basically I can say I will consider all the multiples of g which is less than or equals to n. So I hope this thing is clear to everyone. Now let me just give you some examples. So let's say the value of n is equals to 5. Here I have I'm considering the value of n is equals to 5. Now what if the value of k is equals to 3? Or I can say, what if the value of g is equals to 3? How many pairs exist? So the number of pairs that exist is simply 0, 3, then 1, 4, their difference, the value of x and y. So I can write it this way. Here I will write the value of x, the value of y, and their difference, y minus x. So the value of x is equals to, can be equals to 0. So if the value of x is equals to 0, the possible value of y, which is x plus g, right? So this is a 0 plus 3, which is equals to 3. And now their difference is equals to 3. Their difference is equals to g, or I can say equals to 3. If I select the value of x, if I select the value of y as g plus x. Now if I select the value of x as 1, then what will be my answer? So in this case, I have to select 4. 3 plus 1. Now the difference is a 3, which is equals to g, right? And here in this case, can I select 2? Yes, I can select 2. Now in this case, the value of y will be 2 plus 3, which is equals to 5. So 5. And here in this case, the difference is 3. Now can I select the value of x as 4 or x as 3? Can I select the value of x as 3? So if you select the value of x as 3, then the value of y will be equals to g plus x, that is 3 plus 3 plus 3, which is equals to 6. And this is not possible. This is not possible, because here in this case the value of y must be less than or equals to n. That's why I have written this. I have written this equation. That is the value of y, or I can say g plus x must be less than or equals to n. This is nothing but my value of y. And if y is less than or equals to n, then we all know that x is also less than or equals to n. And what is the value of y? This is nothing but g plus x. And how many possibilities we have for x? So the possibilities we have for x is nothing but from 0 to n minus g, right? And here this g belongs to set S. And what is this set S? So this is nothing but the multiple of k, which is less than or equals to n. Cool. So the possible values for x we can have as 0, 1, 2, 3, and up to n minus g. These are the possible values of x we can have. So if it sounds confusing to you, I can give you some another example. So let's say n is equals to 5 and the value of g is equals to 1. So in this case, what will be your answer if the value of g is equals to 1? So how many pairs we have whose difference is equals to 1? So possible values of x and possible values of y. So if I select this thing, x is equals to 0. Yes, I can select x is equals to 0 and y is equals to 1. Can I select x is equals to 1? Yes, I can select x is equals to 1 and y is equals to 2. Can I select x is equals to 2? Yes, then I have to select y is equals to 3. And this is nothing but x plus g. Super straightforward. Or I can say x plus 1. Then here for 3, I will select 4. For 4, I will select 5, right? So how many pairs we have here? How many pairs we have? Isn't it n minus g, n minus g, and plus 1, because we also have to consider this case 0, where the value of x is equals to 0. So the value of n is equals to 5, the value of g, which is equals to 1, and plus 1 for this 0, which is equals to 5. So we have 5 pairs. If you use this formula here, then you can say, here in this case the number of pairs is nothing but n minus g plus 1, right? Plus 1 because of x is, because this x is equals to 0 wala case. So this is 5 minus 3 and plus 1, which is equals to 3. And these are the 3 pairs. So let me just generalize the equation that what is my answer. So we all know the largest multiple of k, which is less than or equals to n. It is a cnt into k, and the value of cnt is n divided by k. So cnt into k is the largest multiple of x, which is largest multiple of k, which is less than or equals to n. So my answer is simply equals to n minus 0 into k. So here this is the value of g. So n minus g is equals to 0 and plus 1, because we know that I have to handle this case where my value of x is equals to 0. I know I have to handle this case, so that's why I have added 1, plus n minus k plus 1, then plus n minus 2k plus 1, and up to n minus cnt into k and plus 1, because this is the largest multiple of n, largest multiple of k. So I can also separate these three values of every term, and I can write in a, I can just simply simplify this equation. I can say this is nothing but count plus 1 and multiplied by n. So here I have taken this n as a common. So how many occurrences of n we have? We have count plus 1 occurrences of n. So count plus 1, let me write it this way. So this is count plus 1 and multiplied by n. These many occurrences of n we have. So I can write in this way. Cool. And then minus what? Minus a 0. Now I'm going to write these terms. 0 into k, 1 into k, 2 into k, up to cnt into k. So here I have taken this minus outside the bracket. So this is nothing but minus 0 into k plus 1 into k plus 2 into k and up to count into k, right? And what about this 1? So we have 1 plus 1 in each term. And how many terms we have? We have count plus 1 number of terms. So plus count plus 1, count plus 1 and multiplied by 1, or you can say just simply count plus 1. Cool. So these values I can find in a constant time, but for this middle term I can further optimize this. So count plus 1 multiplied by n minus, I can take this k as common. So let's just take this k common. So this is 1. I'm not going to write this first term, which is 0 into k, which is equals to 0. So 1 plus 2 plus 3 plus 4 up to count, right? And then here we have rest of the terms, which is count plus 1. So this is count and plus 1. So this is nothing but the sum of first and first count a natural number. So I can simply write it this way: count plus 1 multiplied by n minus k into count plus 1 multiplied by count and divided by 2. This is sum of first count a natural number and then plus count plus 1. So this is my final answer. And I can find the value of this expression in a constant time. So clear to everyone? Quickly write a plus 1 if this formula is clear to you. Yes, Shubh. Framing such type of equation is really a big challenging task, especially for the beginners. But you just only need to figure out that we need to check for every multiple of k which is less than or equals to n. And once you concluded this statement, then I don't think the problem is very hard. You just have to write the equations and which is very clearly visible. So I guess now we are good to discuss the third problem of the contest. Convert a string. So you are given two strings S and T consisting of a lowercase English letters. You are allowed to perform the following operation on S. Choose an index I and insert a new character immediately after the ith character. The newly inserted character must be different from the ith character. We can pick some index I and we can insert any character other than S of I after index I, and we need to determine whether it is possible to convert S into T by performing any number of operation, possibly 0. So let's see how we can solve this problem. And this is a bit tricky problem. You need to figure out some edge cases, and which is definitely possible after checking for the multiple examples. So let me explain you the first example. The value of x is equals to ABC, and the value of t is equals to a double b and double c. So a, b and c the value of t is equals to a, b, b, then c and c. Makes sense. So here what I can do, I can select the value of I is equals to 0. I can select the value of I is equals to 0, and I will just simply insert character B after index 0. So my new string S will become A, B, B, and C. Now after this, I will perform one more operation, and I will select the value of I as 2. I will select the value of I as 2, basically this index, and previously I have selected index 0. Now what character I will insert? I will insert a character C, which is not equals to B, S of I. So now my resulting string would be A, B, B, then C and C. Cool. Now you can see it is equals to T, so I will simply return true. It is possible to convert S into T. Now how we can solve this problem? So here in this problem, it is always possible to convert S into T if S is a subsequence of T. And we have one edge case. So now let's just discuss how it is possible if S is a subsequence of T. So one and only observation that you require, that it is always possible to convert S into T if S, string S, is a subsequence of string T. So what does I mean by the subsequence? Subsequence simply means we have all the characters of S in a string T in the same order, right? So let's say here we have A. There is an edge case which involves that here. So let's say here we have A and here we have A. So this is my string S, and this is my string T. Now let's say after this we have B, and at here we have D. And after this, let's say we have some characters, and then we have character C, then I have character D, and then I have character A, and so on. Cool. Now let's say at here, after one character we have a character C, then we have a character D, and let's say finally we have a character A at here, right? So now there's all the characters of A is present in a string T in the same order, or I can say string S is a subsequence of string T. Now my claim is that it is always possible to transform S into T. And why is it so? So if we have some character here, so let's say here we have B and here we have D. This is the first position where we have a different characters. So what I will do, I will simply insert B. I will simply insert a D. Here I will simply insert T. Cool. Now what about this B? So this B is not a part. So actually it is not a subsequence. So let me write some case where this B is a subsequence. So here I can say, let's say here I'm assuming that we have a character B. Here I'm assuming that we have character B. So this is clearly mentioned in the problem statement that it is not possible that the length of the string S is greater than T. The length of string S is always less than or equals to the length of string T. length of string t. Cool. So in this case, I can write in this way. So in this case, I will just simply insert d after index 0, right? And now what about this b? So now we got this substring which is equals to this substring. Now what about the other positions? So at this position, what I will insert? What ideally we should insert? So here I will insert some character which is at here. So let's say here we have multiple occurrences of C. So here we have, let's say, multiple occurrences of C, or I can say, okay, let's just do not consider it this way, because taking the large example may be a bit confusing for everyone here, because as I have to draw a lot of casework. So I will discuss the same example which was given in the first test case. So we have a character A, character B, and character C. Then my string S, which was equals to A, B, B, and here we have two occurrences of C. So now this S is a subsequence of this string T. So what happened in this case? So we all know that these two characters got matched, which is our edge case. Now here I will just simply insert B, right? So if I want to pump the occurrences of this character, if I want to pump the occurrences of this character B, then what I have to do? I will just simply pick this index 0. I will simply pick the index 0 and keep on inserting the B, inserting the character B. So I can obtain any I can obtain any frequency of this character B. Now what if we want some other character? So if you want some other character in between A and B, then also you can pick this character A and insert that character, right? And with that character you can just simply pick this index 1 and keep on inserting B. Cool. Now some of you might wondering that what if we have B here? So in this case, if you have B here, so now both the characters got matched. So in this case, we don't have to perform any operation. Now what about this? What about these character, which is at here? So let's say here we have instead of writing in this way, we always write the subsequence. So this is my character B. Now what about what about this B? So I have inserted one B at here. I have inserted one B by selecting the value of I is equals to 0. Now now we all know that these two got matched. Now what next? After this, I have to insert this C. I have to insert this character C. So to insert a character C, what I will do? I will just simply pick the last character which was not equals to C and keep on adding C. Basically the number of C that we required. Now some of you might wondering what we have some other characters after this. Let's say we have some other character and it is equals to E. So if you want to generate some other character, just simply pick this last character, right? I will pick this last character and then I will keep on adding this E. So first I will add one occurrence of E. Then again I will add one occurrence of E by selecting this character C, right? So a very straightforward logic. You can generate any character. Let's say you have a character C. So if you want to have the frequency of more frequency of C, then you can simply pick the character which is before this C. So let's say we have before this C we have A. So every time I will select this A and I can pump the frequency of this C, right? Now, and if you want any other character after the C, then you can generate that character as well. Now if you want some other character after the C, then what you can do, you can just pick this character C and insert that character which you want, right? So what I'm trying to say, it is always possible, but there is an edge case. So let's just quickly check what edge case we have. So let's say this is your string S and this is your string T, and at a string S we have a first character as A, and the second character and the first character of a string T is B. Now tell me guys, is it possible to insert anything at index 0? Is it possible to insert anything at index 0? No, it is not possible to insert anything at index 0, right? So this is an edge case. The character at index 0 must be equals to the character must be equal. So if here we have A, then here also we must have A. Yes, Akash, we can solve such problem with the help of a backward induction. Well, we first derive the solution for the smaller length of strings, and then we keep on increasing the length and will generalize the solution. So now let's say at index 0 we have the same character. Then at index 1 we have a character A. We have a character A in a string T at index 1. Now tell me guys, is there any other possibility? No, we do not have any other possibility, right? So let's say in a string S you have a character B. So in this case we all know it is not possible to insert another A after this 0. It is not possible to insert another A. So what I'm trying to say, as long as we have the same character in a string T which starts from index 0, we must have the same character in a string A. Now let's say at here we have A. Now let's just fix for the next position. So let's say here we have D and here we have another A. So in this case, it is not possible to insert a A here. This is not possible. You cannot insert A here. So we must have the frequency, this prefix the same. And here if we have a B, then here we can have anything. Now here this position is free, but as long as you have the same character in the prefix, it must be same as the prefix of same length, at least the same length in string S. These two prefixes must be same, and these are the only two edge cases we have. This is the only edge case we have. Now let me just quickly summarize the entire solution. So first you have to check whether this condition is satisfied or not, and if it is not, then return false. It is not possible to transform S into T. Otherwise, I will just simply check whether S is a subsequence of T or not. And if it is a subsequence, then it is always possible to transform S into T. Now let me just show you the implementation. And this was the implementation of previous problem. Here my mod, then this is the value of n into k. Basically the count n divided by k. Then this is my first term, count plus 1 multiplied by n. What we have? Yeah, basically this simple expression you have to implement. So then I have to subtract this k multiplied by the sum of first count a natural number. And since we are subtracting something, so make sure to add mod, then again take a mod as the values might be negative. Then after this, I will add count plus 1 and again take the mod and finally return this answer. So coming back to the solution of the third problem. So this is the solution. Initialize. I have initialized two variables I and j with 0. I for the string s and j for string t. Now n is the size of string s and m is the size of string t. Now this is my first edge case. As long as t of j is equals to s of 0, we have to keep on incrementing the value of I and value of j. Right? And if at any moment of time we get that s of I not equals to t of j, then I can just simply return false. And this is another edge case. There might be the case when the length of string j is greater than or equals to n. So what I'm trying to say, after moving this I pointer. So let's say you have a string s 3 times a and we have a string t 4 times a. So now here in my implementation, what I have did, I will just simply iterate over the indices, and while the value of I is less than n and the value of j is less than m, where m is the length of string t. So what I'm checking for. So if these two characters got match, it's an happy case. Cool. Then I will check if this character a, if it is equals to the previous character, or I can say if it is equals to s of 0. This is as per my implementation. If these two characters are same, then s of 1 must be equals to t of 1, and if it is not, then I will return false, right? But here in this case it is true. Then I will check for the next index. I am checking this character a with the first character of a string s. So if these two characters are same, then it must be same as the character which is at the same index. Cool. Now here we miss some edge cases. Now the value of I, which is equals to n, and now here you have to check after the loop that whether we have some more characters to process in string j or not, which are same. And if we have some more characters to process, then I will just simply return false. So simply return false. This will be my answer. So return false. Otherwise, I am simply checking whether string s is a subsequence of t or not. So if s of I is equal to t of j, then I will just simply do I plus plus. Cool. Take me to the next index. Otherwise, I will do j plus plus. If the characters are not same. If the characters are not same, then I have to insert. I have to select an index. And finally, I am checking whether the value of I is equals to n or not. N or not. If they are equal, then this simply means we got a subsequence. Now coming back to the last problem. Coming to the last problem of the contest. Count n digit number. So the same problem has appeared in the contest 187. So in this problem, you have been given an integer n and you need to find the n digit number formed using digits from 1 to 9, such that the GCD of the digits of the number is greater than 1. Just please try to pay more attention. Here we want the GCD to be greater than 1. We don't actually need to care what is the value of GCD, but it must be greater than 1. And we need to find how many such number of length n we can form, where we have the digits from 1 to 9. And since answer can be very large, so we have to print the answer under modulus 10 power 9 plus 7. Cool. Now let's see how we can solve this problem. For n is equals to 1. So how many numbers which has one digit and a GCD is greater than 1? So in this case, the GCD of 1 is 1, and for rest of the digits, the GCD is greater than 1. So that's why we have 8 possibility from 2 to 9. So now let's just discuss the solution. So the first thing, I need to form n digit number. N digit number. Now what are the possibilities for digits we have? So we have a digit 1, 2, 3, 4, 5, 6, 7, 8 and 9, right? So we with these possibility of digit, I have to form a number of length n. Cool. And such that the GCD of digits of a number must be greater than 1. I don't need to care what the value of GCD is, but it must be greater than 1. Cool. So I can break this thing into a multiple cases. So let's just write a case 1. Case 1. So let's just first count number of digits whose GCD is a multiple of 2. Number of digits whose GCD is a multiple of 2. Cool. So what are the multiple of 2 we have? So multiple of 2, which is 2 itself. Then we have 4. Next multiple of 2. Then 6 and 8. Right. So we have to form a number of n digit. So that this simply means that we have n options, n positions that I have to fill. So here in this case, let's say the value of n is equals to 5. I mean, I have to form a number of length 5. So in this case, what are the options we have? If you pick any odd number, here in this case, let's say I pick 3. So if you pick any odd number, then the GCD will become equals to 2, equals to 1. So in this case, the GCD of 3, comma 2, it is equals to 1. So this is an invalid case. So I cannot pick any odd number. But can I pick a even number? Yes, you can pick any combination of even numbers, right? So this simply means for every position I have 4 possibility. I can pick any of these 4 integers, 2, 4, 6 and 8. So 4 possibilities for here. Then 4 possibility I have for this second position. Then 4 possibility here. Then 4 possibility here and 4 possibility here. Now if you form any n digit number with 4 possibilities, then what you will get? You will get a number whose GCD is a multiple of 2, right? So how many possibilities we have? We can place we have 4 possibilities for every index. So my answer, or I can say here in this case, we have how many such number we can form? This is nothing but a 4 to the power n, right? N indices, n positions we have, and for every position 4 possibility. So 4 into n. Cool. So this simply means I have covered all the cases where the GCD is 2. I have covered all the cases where the GCD is 4. I have covered all the cases where the GCD is 6. I have covered all the cases where the GCD is 8. Cool. Now let's just write another case. Case 2. So here I will count the number of digits, or I can say count a number of n digit numbers. I can say count a number of n digit numbers whose GCD is a multiple of 3, so that I can cover the odd wala case whose GCD is a multiple of 3. So here also I mean the same thing. I meant the same thing. So count a number of n digit numbers. N digits number. Whose GCD is a multiple of 2. So how many numbers we have? So I have 3, then a 6 and 9. These are the digits which are multiple of 3. So I have n positions, 1, 2, 3 and 4. And now I have to fill these positions. So I can give the same example. If you consider any even number, then the GCD will become equals to 1. GCD will simply becomes equals to 1. So in this case, I must have to place these 3 numbers at every position. Any of these 3 numbers at every position. So this simply means 3 possibility for this, then 3 possibility for this number, 3 possibility for this number, 3 possibility for this number, and 3 possibility for this number. So overall, this is 3 to the power n. Cool. Now the next case. Here I have covered all the numbers, all the n length number where the GCD is a multiple of 3. So this case, then this case, which I have covered twice. I have covered when I was considering the multiple of 2, and I have covered this now as well when it is a multiple of 3, and I have covered this one too. So I have to subtract the contribution of 6 one time. That is, I have to subtract the numbers where the GCD is 6, because this is now counted twice. So case 3. So case 3, let's just subtract the numbers where the GCD is a 6. So I can say a GCD as a 6. So how many such numbers we have where the GCD is 6? So GCD 6 is only possible when you place 6 at all the n positions. So I can say only one possibility, right? And I have added this one twice, so I will subtract it once. Now case 4, where we have a GCD as 5. So again, only one possibility, when you place 5 at all the position, then only the GCD is equals to 5. If at any position, if you place some different thing, some different digit, then the GCD will not equals to 5. So I can say 1. Then similarly, we have a final case, case 7. Case 5, where the GCD we have as 7. So GCD as 7. So GCD 7 is only possible when we place 7 at all the positions. So this is nothing but 1. So my final answer, my total answer is equals to 4 to the power n plus 3 to the power n, and 4 to the power n plus 3 to the power n covered the GCD as 6 wala case twice. So I have to subtract it once. So minus 1 and plus 1 and again plus 1. So overall, this is 4 to the power n plus 3 to the power n and plus 1. This is my answer. So let me just show you the implementation. So here we have our power function, and this is the method that you need to complete. Here is my mod variable 10 power 9 plus 7. Then this is 4 to the power n plus 3 to the power n and plus 1. And to calculate this value, here I have used the modular arithmetic. Right? And take the mod. There's a modular, this is a binary exponentiation which will return you the value of a to the power b in just log of b time. So the time complexity will be log of n base 2 time. This is the time complexity. So I hope this is clear to everyone. And if there was something which is not clear to you, then you can watch the recording of this session. So if you have any doubt, then you can write your doubt in the chat box. Otherwise, we are good to wrap this session. This was all from my end. And make sure to hit the like button if you have learned something new. And also subscribe the channel to get the more upcoming videos quickly. So I guess no doubt so far. Thank you so much everyone and have a good day.
We all know that the tech job market has become really challenging, and it is not always going to be like this. Seeing all this, we have come up with something that we never offer. You all know that we have been doing this 390 challenge where you finish 90% of the course. In 90 days, you get 90% of the cost. In addition to this, we have also reduced the upfront fee by 30%. So make the best use of this and invest in your skills, the all-time most valuable asset.